Hello. So today we're gonna follow up from the previous video that I posted on process control. This is gonna be process control video. Process control. So there are two things that I want us to understand is that if you are given f of t is equals to 1, let's say this is a constant, it's equals to 1, which is a constant, then the Laplace transform of that f of t is gonna become 1 over s, right? But s has to be greater than 0 because it's gonna be undefined, obviously. This is just the conditions, it's not gonna be undefined, but this is just the conditions that was included when you are driving this Laplace transform. You can try to do this thing. Let's say we know that the Laplace transform of f of t is equals to 0 to infinity of f of t e negative s of t dt. So let's say f of t is equals to 1 and see what we get. So 0 infinity 1 e negative s of t dt. So this, when you integrate this, it's gonna become e negative st over negative s, right? So that becomes how you integrate this. They're integrating from 0 to infinity, right? So if you do this, you put the infinity, let's say you say e negative s times infinity over negative s minus e negative s times 0 over negative s. So if you set your conditions, so you're gonna say s is greater than 0. If s is greater than 0, this thing is gonna converges to 0 under these conditions. So this thing is gonna converge to 0. So minus this one is 1 over minus s. So now this becomes 1 over s. Can you see? So that's how we get this. You can always try to prove all the Laplace transforms that we're gonna mention using this same procedure, right? So that's very important, especially because you're gonna have constants in your differential equations, right? So then another one that I proved in the last video was that if f of t is equals to e a of t, therefore the Laplace transform is gonna be 1 over s minus a. Similarly, if f of t is equals to e negative a of t, the Laplace transform is going to become 1 over s plus a. This is very important. You will see when we do an example that has to do with the applications of these two concepts, right? So another one that is important is that if you have d over dt, then the Laplace transform is s y of s minus y of naught. This is also very important, Laplace transform. So the ones that I ticked, okay, all of them that were discussed so far, very important Laplace transforms, right? Okay, that's good. So if you just have